Hey everybody, Adam here. Hope everybody's doing well. You know I got a special video for you today because I'm wearing my fancy glasses and my fancy hat. I only break these out for special occasions, weddings, bar mitzvahs, bat mitzvahs, occasionally funerals. Depends how important the person was. I will not wear them to your birthday party unless you happen to be a small child, because that is for whom birthday parties were intended. Small children. Grown-up, mature adults should not throw themselves birthday parties. And if you do throw yourself one, I will not dignify it by wearing fancy apparel, nor will I validate it with my presence whatsoever. So I guess that was a moot point. Anyway, now that we got all the important information out of the way, we can move on to the thing that I'm sure nobody came here for, the boring deck I just built for the courtyard of our new house. So without any further ado, let's travel back in time and get to it. Alright, so here's where I'm at thus far. As you can see, I'm just starting to get the joists set up. This is such a simple assembly. I'm not going to waste any time breaking this up into lots of little steps. Just a few broad overviews, and I think you'll get the gist of it. So my foundation for the deck is simply a big, thick pit of 1-inch crushed rock, or as the layman's call it, gravel. That's serving a handful of functions. Primarily, it's bringing the joists high above the ground so they're not ever sitting on wet, soggy dirt. It's also allowing me to achieve the exact height that I need so that the top of the deck lines up perfectly with the edge of the slab. And it's also just functioning as a giant drain and a giant capillary break. Next, underneath the joist, you can see I've got these concrete block caps. Those are 1.5 inches thick, 8 by 16. And those are basically just functioning like snowshoes. Hopefully that makes perfect sense. They're keeping the joists from sinking down into the crushed rock. And they work surprisingly well. I've pushed down on them as hard as I can. I've stood on them. Once you got them in place, they don't sink at all. In between the joists and the blocks, I've got this, maybe not be able to see it that well, but this polyethylene sill seal. It's this stuff right over here. And that's just serving as a capillary break between the blocks and the boards, because when these blocks get wet, they're going to soak up a ton of water like a sponge, and I don't want that water wicking up from the blocks into the wood. So that's what that's doing. And I'm using polyethylene for its weather resistance. The joists themselves are 2 pressure treated 2x4s sistered together. Now the reason I did that was simply because I can never find straight pressure treated 4x4s. Anytime I try to find a straight pressure treated 4x4, I'm digging through the whole pile, and I'm lucky if I find 1 or 2. I don't know why, that's just always the case. On the other hand, these boards, or these 2x4s, were all perfectly straight. So I said, screw it, it's the same thing basically. Cost was about the same. I might have saved a few pennies per board doing it this way. Not a big deal really. And structurally, no significant difference. Technically, a true 4x4 would be a 1/2 inch thicker in one direction, but again, that's just not going to make much of a difference. Some of you might have noticed this detail over here. So I'm insulating around the edge of the slab. So I'm also going to insulate on top of the slab and then bring aluminum roll flashing down over that. So of course I have to set up this insulation before the deck covers it. This is 1/2 inch of polyisocyanurate. That's a closed cell rigid foam. It's got some water resistance, but you don't want to let it get soaking wet. But if it gets a little bit wet, that's not going to be a big deal. However, as you can see, it has this aluminum foil facing on it, which is serving
as a water and vapor barrier. It's also a radiant barrier, but that doesn't really matter when you're putting it under a deck. You can see I've also taped the edges, the seams. That's a weatherproof permanent bonding tape. And again, there's going to be aluminum flashing coming down over it, so it's going to be well protected. I didn't have enough tape to tape the bottom, so I just put a coat of paint on the bottom edge, but it's not even touching the ground, so it really shouldn't be a big deal. And for right now, I think that pretty much covers it. I guess I should mention this is quite literally going to be a floating deck. It's not fastened to the ground, it's not connected to the building, and I'm essentially just building a giant raft. So that's the plan, and I will come back when I've done some more. All right, so as you can see, I started putting down some deck boards in that corner over there. But before I talk about those, there are some other details I want to point out, and also some important details and tips I want to circle back to that I should have mentioned earlier for anyone who is maybe building a similar deck, or for those of you who just might have some general curiosities. So let's start again with this crushed rock. Getting this in here and getting it to the correct height and leveling it could have been a real pain in the wazoo, because the ground at that corner is about 4 inches lower than the ground at that corner. So quite a considerable slope. So what I did was I simply took a Sharpie and my tape measure, and I just went around the slab and I made a dotted line. I knew the gravel needed to be 6 inches below the top of the slab, so I just measured 6 inches down and dashed a line around it. And then all I had to do was just start filling the gravel around the edge up to that line, and then I was able to work my way back from there, and at that point it was pretty easy to just eyeball it. So I think that made it a lot simpler than if I was just doing a lot of guesswork and trying to get it right with my carpenter's level. Which brings me to these blocks and the joists. So to get the blocks and the joist level, that first row of blocks, I leveled each block individually in all directions using this tiny little level for ants. And then once I got those perfect, each successive row, I just leveled off the previous row with my trusty carpenter's level that's somewhere over there. As for the joist spacing, so from right to left, I'm going about 24 inches on center. From back to front, I've got about 16 inches in between the blocks. When you're using wide joists and thick boards, you can get away with a little wider spacing. And I assure you this is plenty solid. I've already walked all over that a bunch. Now I do have to warn you, if you're trying to do some kind of a fancy pattern with your deck boards, that joist spacing needs to be meticulous and precise, and you might also have to add blocking in between the joists, because you need to really ensure that every deck board lines up perfectly with the joist. I'm just doing a simple straight line, so I don't have to worry about that so much. Something else I should have mentioned when I was talking about this sill seal that I put under the joists. Code does not require that when you're using pressure treated wood, whether the wood is touching concrete or even the ground. As long as it's ground contact pressure treated, you don't need the sill seal, and this is severe weather ground contact pressure treated, so I didn't have to do that detail. I'm just going that extra mile because I want to. I really want this deck to last a lifetime, and in my climate I think that's possible as long as I take all the necessary steps. And that sill seal, that polyethylene, it's so cheap and it's such an easy step that even if it only extends the deck's life by 1 or 2 years, I think it's worth it. Next, let's talk a little bit more about this insulation, because I realize that might, you know, my Taryn, my wife, for those of you who aren't in the loop, she pointed out to me last night that might be confusing to some people. It's not the most common thing that you see. So first I should mention that, because I don't think I mentioned this yesterday, it's actually being held to the slab with 2 really thick beads of construction adhesive. The tape is not holding it to the slab. The tape is just a water sealing detail. And just in this deck area, it's 1.5 inches below the top of the slab, and that is to give me a space for my deck board, or deck boards I should say, not just one of them, but all of the ones that need to meet the edge of the slab. Now when I do this detail around the rest of the slab, I'm going to go all the way from the ground right up to the top, and then I'm going to come across the top with another piece that's going to overlap so it's continuous, and that's going to perform a lot better. In this area right here, it's sort of like a better than nothing type of situation. And I questioned many times, is it worth it? I mean, it's just a 1/2 inch of foam. What's it really going to do? It's only adding R2.7 to the edge of the slab, which doesn't sound like a lot, but it's a whole lot more than R0. And it's important because the edge of the slab can really lose a lot of heat during the winter months, especially when it's above grade like this. And conversely, in the summer, if sunlight's hitting it, it can gain a lot of heat. So that's the point of that detail. And that'll also make a lot more sense when I do the floors, because I'm going to put that same kind of foam down on the floors. So it's almost like continuous insulation from the inside to the outside, except for this break where the wall frames are. Now let's talk about the deck boards. So these are 2x6 pre-cut studs, Douglas fir. I like using the pre-cuts whenever I can for 2 main reasons. First and foremost, my experience has always been that they are a better value per board foot. So for example, right now, a full-length 8-foot 2x6 costs about $3 more than one of these pre-cuts, but you only get an extra 3.5 inches of wood. So you're paying almost $1 per extra inch of wood, which is insane. The other reason I like to use the pre-cuts when I can is because they're all cut to exactly the same length. When you're working with regular full-length studs, they might say it's an 8-foot board or a 10-foot board, etc. But then when you measure each board, you find out that one of them is 8 1/4, and another is 8 1/2, and another is 8 3/8. And then you got to sort through all these boards and trim off these little slivers off the ends to make them all the same length, and it's just such a tedious pain in the you-know-what. So yeah, when I can, I like to use the pre-cuts. I also decided to go with a 2x6 or 2x board instead of a traditional deck board, because a traditional deck board is exactly 1 1/4 inches thick. These are exactly 1 1/2 inches thick, so I've got that extra 1/4 inch of material, which should most likely extend the life of the boards. As you can see here, using a pretty beefy 1/4 inch gap between the boards. I have this pair of scissors right here that just happens to be about a 1/4 inch thick when the blades are closed, so that's my spacer. And then I like to give it just a little wiggle to add a millimeter or two, so it's really probably more like something between a 1/4 and 3/8. I want a nice wide gap because I want the water to drain through very quickly and dry out very quickly. And I'll show you a little trick here. This is how I'm getting pretty much perfect spacing between my screws. So my boards are 5.5 inches wide. So I take my speed square here, I just line that edge up to the board, and then I make a mark at the 1 inch line and at the 4.5-inch line. So then I have exactly 1 inch on each side, and then boop, drop my screw in. And I use the straight edge to keep them all in a line. So just a little tip. And yeah, so for right now, I think that will do it. Probably a good place to leave off. And yeah, I'll come back when I'm a lot closer to being finished.
All right, it's about a month later, and as you can see, I'm finished with the deck. Altogether, it took about 2 months to do, and you know, it only took that long because honestly, I just had a lot of setbacks recently. We had to go through the holidays, we had to get one of our dogs neutered, that little guy over there, and then I had to keep a close eye on him for about a week. Lots of rain, a little bit of snow, a lot of windstorms. We just went through our second rainy season. It's the middle of winter. Oh, my dad died. Yeah, that goes. Real pain in the wazoo. Parents always dying on you right when you're in the middle of something. I'm like, dude, could you just hold out another month? I gotta finish this deck. Oh, but my cancer, it's metastasized. Well, I got work to do, man. Just relax. Cancer's not going anywhere. Just settle down. No, don't settle that far down. So yeah, you know, what can you do? If it weren't for all those setbacks, I probably would have banged it out in like a month. Anyway, that's enough of that. Let's get on to the details. I guess I'll start with the finish. So this is a red tinted timber oil. That's it right over there. Got 5 gallons of it, only used about half of it, and to put 2 coats on. So I'm surprised how far that stuff stretched. Timber oil is not the same as stain. I should mention that. The simple explanation is stain is just a surface level, superficial detail. All it does is it changes the color of the wood, and if it's a dark stain, it might give it some UV protection, but that's about it. Whereas timber oil is meant to put back the oils you would otherwise find in a tree if you didn't cut it down and mill it and put it in an oven and turn it into a deck. So that's the concept there. So it actually seeps down into the grain pretty deeply and just gives the wood a lot more protection. I reckon this seeped into the wood about 1/4 of an inch. And so it's not like you can just stain this off like most other finishes. And I know that for a fact because I found out the hard way. They say on the label it says the dry time is 24 hours. But it's not really a drying process as much as it is a curing process. So it might appear to be dry the next day, as in you can touch it and you won't rub any off or get any on you. But it's still not finished curing, especially if the weather's cold, like it's been very cold here. It's winter time. So I've learned you should really let it cure for about 7 days at minimum, because what happens is if you don't and you walk around on it with rubber-soled shoes or boots, you'll leave black stains and streaks all over the deck, which is what I did, which is why I'm wearing these really fashionable shoe covers right now. So yeah, we ended up having to sand the whole deck again, and big ups to my wife for helping me out a lot with the sanding. It saved me a lot of time. But yeah, she ended up resanding the whole entire thing, and it didn't take it back to its true color. It still had a tint to it. So that's how I know that oil really did get deep down in there. Guess we'll talk about these steps over here and this trim. So got a step here going into the house, and this is to make this flush with the floor when the floor gets put in the house. And we kind of just like the look of it. As you can see, I did not put that same oil on the trim around it, nor did I do it on the step into the outdoor kitchen. Instead, I'm going to use the same oil that I'm going to put on the exterior cladding of the house, so that trim will match the cladding. It's more of a golden honey color. I just think it's a nice touch. It's also safety detail because it clearly delineates the edges of those steps, so there's no camouflage effect going on. Anyone could see clearly that there's a step there, and that's mostly for myself because I'm going to be getting super drunk on this deck all the time, and I know I'm going to fall a lot. So anything I can do to minimize the tripping and falling is helpful. Also, this is in fact the world's largest step because it's not steps, it's just a step coming in at a whopping 4.5 feet by 6 feet. And then over here we also have another bit of an architectural enigma, which is that this is a step, but it's also a floor. So it's my own little invention right there. Obviously, I'm just being a jokester. Next up, let's talk about the fire pit area. So when I was originally designing the deck, and actually, you know what, let me back up for a second here. The reason I keep referring to this area as the courtyard or the courtyard deck or the courtyard kitchen is because I'm pretentious. But it's also because I'm building walls around here when the house is finished. So technically more of a courtyard than just a deck. I mean, what do you think, I'm going to build just a deck? Some kind of loser? So anyways, once those walls go up here, and then we're going to put a gate right here, we're going to, whenever we have to leave for the day, we're going to lock the dogs in here like the prisoners that they are, because we quite sorry, tripping over my words here, we quite literally kidnapped them. We abducted them from that highway over there. And so since we are officially their captors, and they now have a pretty serious case of Stockholm Syndrome, I think it will be safe to leave them in this minimum security prison during the day while we're out. And they'll have a little doggy door over here where they can go in and out of the house. So when I designed the deck, I thought, you know, it'd be nice if they had somewhere they could pee, because I hate the idea of leaving them home for 8, 9, 10 hours with nowhere to pee. I think it's cruel. So originally I was envisioning just maybe like some kind of a small hole somewhere here that would just go to the ground, and then I could train them to pee there. But then my wife really wanted to add this fire pit. And by the way, the only reason there's a concrete block in there is I just wanted to see if it would combust. No, it's just there to weigh it down so the wind doesn't blow it over. But yeah, she wanted to add this fire pit onto the deck because she's a brilliant building scientist like that. So then I figured, well, I've got to make a fire break. So why not kill two birds with one stone? And so yeah, this is 1 part fire break, so just in case any embers fly out, they don't land on the wood, and 1 part doggy pee-pee area. Hey, watch it, man. You're always trying to break my neck, dude. No, settle down. I'm trying to make a video. No, get away from me. Anyway, sorry, I lost my train of thought for a second here. So basically this is just a big pit of gravel. It's actually about 2 tons of gravel, if you can believe it. It goes straight to the ground. However, nothing about the assembly has really changed here. The way I set up my joists and my blocks is still the same. And in fact, there are 2 joists running right through here. You just can't see them because they're buried in gravel. The only slight difference is right here and right there. I reinforced those spots with some stacked up concrete blocks and a piece of foam. And I felt that necessary because a bench is going to go here and a bench is going to go there. So there's going to be a lot of sitting down and standing up on those spots. So I figured, yeah, give them a little extra support just so the boards don't end up sagging over time. Talk about the flashing. So this is galvanized steel, and it's primarily just a visual detail. When you put your boards in a straight line like I did instead of staggering them, you end up with a pretty crooked seam over a long distance. So that's just to tighten up that seam, excuse me, kind of make it look a little more finished, a little more professional. And then I figured, well, if I'm gonna go all the way down the center here, then I might as well also go around the edges. So I also did the galvanized steel drip edge all the way around there. And though it's primarily a visual detail, it will add some protection to the deck, especially in the center here where these sawn ends of the board are. Those are always the most vulnerable parts of the board. Also, it's probably worth mentioning, when I first put down those boards, when I put the screws down at the very ends of the board, I pre-drilled all of those holes, because if you don't, most of them are almost guaranteed to split, and some of them even split with the pre-drilled holes. So when you get close to the ends of the board, make sure that you pre-drill. Talk about the skirting for a moment here. So these are 2x8s, and my deck joists actually came out a bit longer than I wanted the deck to be. Rather than wasting a bunch of time measuring and cutting ahead of time and trying to get it just right and having to figure out exactly how many boards I need, I just laid down the boards until I got to where I wanted the deck to stop, and then I just came back with a classic handsaw and sawed off the ends of the joists. And that was actually quite easy. It didn't take much time at all. Of course, I was born on Krypton, and my strength is enhanced by the Earth's mighty yellow sun, so hard labor comes naturally to me. It's not actually hard. In fact, it's easy labor. But yeah, so that's how I did that. I'm going to seal this up eventually with crushed rock and big rocks and all kinds of rocks. I'll probably do that. I've got a little left over there, so I'll use up what I've got. And if it's not enough, I'll just finish that when I get the gravel for the entire rest of the yard. Since I'm mentioning the skirt, might as well talk a little bit about pest control. So the biggest threat to this deck in my area is subterranean termites. I did a lot of research on them, and unfortunately what I found out is there's just not much you can do about them outside. Indoors, yes, but outdoors, you're kind of not completely at their mercy. You can take precautions, but there's not a lot of foolproof solutions. Originally, I was going to use this stuff over here. It's over here. Diatomaceous earth. It's like powdered seashells, and it kills crawling insects. And it will kill above ground termites, but I found out it's not very effective at killing the subterranean termites. I actually found a study in Hawaii where they did 5 tests with that stuff, and only 2 out of the 5 tests actually did anything. The other 3 were unsuccessful. I also discovered that that stuff doesn't work outside, because as soon as it gets wet, it's ruined. It's supposed to be a dry powder. If it gets wet, it cakes up and it turns into sort of a plastery type of material. It just stays that way forever, and it's not doing anything at that point. Another solution I looked into was boric acid. Ran into a similar problem. If I use it outdoors, it's not really intended for that. It's intended for indoor use. So, it might work for a little while outdoors, but eventually it's just going to become ineffective. So the solutions are essentially everything I've already done. You want to get the wood high up off the ground. You don't want any wood to ground contact. That's the biggest mistake. The higher, the better. Make it difficult to get to the wood. So like adding like all that crushed rock, it's just one more challenge for them to get through, as opposed to if it was just, right on the regular dirt. Putting a finish on your wood any kind of paint, stain, oil, etc. Anything that's gonna, make it unappetizing to them, essentially. And keeping the area dry as possible. And that goes back to having these wide 1/4 inch gaps so that, sunlight, air, heat can get in there as fast as possible and dry it out as fast as possible. The last thing I want is for it to be like a swamp under here, because that's the kind of habitat they like to live in. Also, real quick, speaking of these gaps, show you something. I quickly discovered a better method for spacing my boards. What I did was I took that thick edge of the speed square, wedged it in between the boards down at one end. That gave me a perfect 1/4 inch gap, and then I just slid it down the rest of the way. And then that gave me a perfectly straight, even gap across, the full board length. So that was a lot faster and more precise than what I was doing before. I just thought I'd share that tip with you. Going back to pest control for a second. So obviously once I bring the ground up to the bottom of the skirt, that will help keep a lot of critters out, though some will still be able to get in for sure. The 1 inch crushed rock, my excavator told me that if you use 1 inch specifically, for example, for a point in time I was thinking of using a 3 inch rock, which is a much smoother rock, more like a river rock. But he told me if you use the 1 inch specifically, rattlesnakes won't nest in it because it's so jagged, it messes up their scales and they just don't like it. So hopefully he's right about that. Yeah, I don't really care much about other insects getting in there, if like spiders get down in there. I know lizards are going to get in there, and that's cool because the lizards eat insects and they don't do any harm. I prefer rodents don't get in there, so, but that's, I'm going to try my best to seal it up as much as I can to keep rodents out, but these tiny little field mice or whatever they are that we have out here, I mean, they can slip right through a gap like that, no problem whatsoever. So I'll have to do some thinking on that. And I'm trying to think if there's anything else I should cover. Oh, back to the termites for a second. Going back to that polyisocyanurate that I talked about in the beginning of the video, the insulation that I started putting around the slab. The reason I went with that instead of a polystyrene product such as EPS or XPS, which would actually be better suited for an outdoor application, is because EPS and XPS attract termites and ants. And when you're building a house out of wood, I think the wood is enough of an attractor. Probably don't want to attract them any more than that. So yeah, the choice to use that foam specifically was also a pest control detail. And why would it have been better to use EPS or XPS? For example, when I get up to the roof, I'll probably switch to EPS because I don't think termites will be a threat up there anymore. But the reason it's better to use those outdoors is because they're more water resistant. They won't sponge up water as much as the polyiso will, and they don't have a thermal drift, which is just a fancy way of saying they'll maintain their R value over their lifespan, whereas the polyiso's R value will gradually decline over the decades. The polyiso R value will also drop a little bit in temperatures below 50 degrees Fahrenheit. So if it's 40 degrees Fahrenheit outside, it's going to go from about R6 per inch down to maybe R4.5 per inch. It's not like it stops working altogether, it's a little less effective. And yeah, I think that truly covers it. I always say this and then I come right back, oh, I forgot. I'm back. Yeah, I forgot something. Some of you might be wondering how I built the floor over here in this area in the kitchen. It's really simple. It's just sleepers and boards. So just laid down some flat pressure treated 2x4s going that way, and then just ran the boards across them. And that's it. The easiest floor you could ever build. And again, it's floating. It's just sitting there being held down by its own weight. It's not fastened to the concrete. It's not glued down or anything like that. So that's important. It's important if you can avoid attaching your floor to the concrete, if you're using wood that is, that, you know, gives it room to do its natural expansion contraction thing, and you'll get less failures. So I've been told. And yeah, so now I think that really does cover it. And I suppose all I could say now is just as I stand here looking around, seeing everything come together, the abundance of sheer alacrity swelling inside of me as this once verisimilitude of an architectural diapason harmoniously becomes as real as the ground upon which it stands. Well, I just can't find any words to describe it.